Good day everyone. Today we're going to discuss about counting techniques, specifically fundamental counting principle. Let's try to explore counting techniques. So supposedly we have here Ace Millie, who is a Filipino Caucasian rapper who is trending on social medias right now because of his song Panalo. His live performance of Panalo on Wish Buzz USA is currently tearing it up on the internet, amassing 10 million views in just 3 days. Suppose he is planning a concert tour in 3 cities, Manila, Cebu, and Davao. In how many ways he arranges his tour schedule? So we have here the first kind of counting techniques that we are going to discuss is a tree diagram. What is a tree diagram? A tree diagram is a systematic way of listing every possibility. So let's try to find out how many schedules or tour schedules of Easy Mail have. So here, if we're going to start, so first stop could be in Manila. The second stop will be in Cebu, or it could be in Cebu, while the third stop will be in Davao. So the first outcome that we have is Manila, Cebu, Davao, first tour schedule. Or it could be the first stop is in Manila and second stop will be in Davao and the third stop will be in Cebu, right? So the second tour schedule would be Manila, Davao, or Cebu. Or the first stop could be Cebu City and the second stop is Manila and the third stop is Davao City. So the third outcome will be Cebu, Manila, Davao. Or could be the second stop Davao while the third stop is Manila. So the could be Cebu, Davao, Manila. Or you can have the first stop in Davao, second stop in Manila, and the third stop in Cebu. So the outcomes would be Davao, Cebu, Manila. Or the first stop in Davao, the second stop will be in Cebu, and the third stop is Manila. So Davao, Manila, Cebu. So that means there will be 6 possible tour schedules of Easy Mail. So let us see, for example, suppose a quiz has only 2 questions. The first is multiple choice question with 4 choices. 2 questions rather. The first is a multiple choice question with 4 choices, A, B, C, or D. The second is a true, false, or TF question. In how many ways can this quiz be answered? So using a tree diagram, we can show or we can find the possible or the every possibility. So first question, it could be A, and the second question, the answer could be true, right? So the outcome could be letter A and a true. It could be the first question is A and the second question is false. So that's the second outcome. It could be the first question, the answer is letter B. The second question is true. So the outcome is letter B and true. Or the first question is B while the second question is F. So the fourth outcome is letter BF. Or the first question will be C, letter C, while the second question, the answer is letter T or true. So that's the fifth outcome. Or the first question is letter C, or the second question is letter F, so the sixth outcome, that's the sixth outcome. Or you could have as the first question as letter D, and the second question is true. So that would be the 7th outcomes. Or the second question would be false, and that makes it the 8th outcome. So in how many ways can this quiz be answered? So there will be 8 possible ways. So here, if a coin is tossed twice, draw a tree diagram to illustrate the possible outcomes. So using a tree diagram, we are going to find how many possible outcomes are if we are going to toss a coin twice. So let's start here. First toss of it could be head, right? Second toss, it could be head. The third toss, it could be head. So the outcome here is head, head, head. Or in the first toss, it could be head. In the second toss, it could be head. Or the third toss, it could be tail. So the second outcome is head, head, tail. Or in the first toss, it could be head. The second toss, it could be tail. In the third toss, it could be head. So the outcome is head, tail, head. Or it could be the first toss, which is head, the second toss is tail, and the third toss is tail, which is the outcome head, tail, tail. Or in the first toss, it could be tail. The second toss could be head. The third toss could be head. So the outcome is tail, head, head. Or it could be in the third toss, it's tail. So the outcome is tail, head, tail. Or the first toss is tail, then the second toss is tail. The third toss could be head, and the outcome is tail, tail, head. Or in the third toss, it could be tail. So that outcome is tail, tail, tail. So how many are possible outcomes when you toss a coin twice? So there are 8 possible outcomes. Supposedly we have this number 2 example. Another device that can be used to find all possible outcomes. This is the second way of finding the possible outcomes using a table. So it is another way the device that can be used to find all possible outcomes when 2 or more experiments are performed together or in a sequence. So we have like 2 dice are rolled. What are the possible outcomes? How many are the possible outcomes? So in here we have the column. We have here dice 1 and dice 2. We all know that a die has 6 numbers, 1, 2, 3, 4, 5, 6. And if you're going to roll a die, so like this one, 1, 1 here, that means when you first roll a die, it could be 1 in the first die, or it could be 1 in the second die. It could be 2 in the second die, at the first die. It could be 1 in the second die. It could be 3 in the first die. It could be 1 in the second die, and so on and so forth. A total of 36 possible outcomes. So these are here 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, and so on. These are the possible outcomes. And a total of 36 possible outcomes. Okay, let's try to recall and analyze the previous examples that we had a while ago. So here, in the concert tour schedule, the first stop choice will be 3. It could be Manila, Cebu, or Davao, right? In the second stop, since you already choose, for example, Manila, so in the second stop, there are two choices already, which is Manila, Cebu or Davao. So in the third stop, there is only one city which is left. So that means in the third stop, you can have one city that you can choose from. So the possible outcomes there is equal to, or the number of possible ways or possible outcomes is 6. And how about in different ways to answer a quiz? So we had there in the first question, there are 4 choices. So that means we have 4 possible outcomes. In the second question, which is a true or false question, so we have 2 possible outcomes. It could be true or false. So how many are the number of possible ways or possible outcomes? The answer there is 8, right? Okay, so in the third example that we had, tossing a coin thrice. In the first toss, the possible outcome is 2 because it could be tail or head. Tail or head. In the second toss, still it could be head or tail, right? In the third toss, it could still be head or tail. And the number of possible ways that we had there is also 8, right? So in the last example, tossing 2 dice. In the first die, there are 6 possible outcomes. Why? Because there are 6 numbers. It could be when you toss the first die, it could be 1, it could be 2, it could be 3, it could be 4, 5, and 6. So there are 6 possible outcomes. While in the second die, there are still 6 possible outcomes. Right? And we all know that the number of possible ways there is 36. Now, do you think we have another way of solving this kind of problem? Aside from showing it in tree diagram and table, is there another way? Just try to check the answers here. In the concertor schedule, why it becomes 6 from 3 to 1? What happened? It becomes 6. In the different ways to answer a quiz, there is 4 and first question and the second question. That becomes 8. In the tossing a coin thrice, why it becomes 8 from first toss, which is 2, from second toss, which is 2, and the third toss, which is 2. And the tossing 2 die, the same with tossing 2 dice. First die we have 6, second die we have 6. So there is easiest way in getting the possible number of outcomes, which is we're just going to multiply every events. So we have here 3 times 2 times 1, that is 6, right? 4 times 2, that is 8. 2 times 2 times 2, that is 8. 6 times 6, that is 36. And what do we call that techniques? And that's what we call the fundamental principle of counting. What is fundamental principle of counting? It is a rule to count all the possible ways for an event to happen, or the total number of possible outcomes in a situation. It states that when there are n ways to do one thing and m ways to do another thing, then the number of ways to do both the things can be obtained by taking their product. This is just to express as n times n. So we will just multiply the ways in doing that one thing and another thing. See, for instance, number 4. In a student council election, there were 4 candidates for president, 3 candidates for vice president, 3 candidates for secretary, and 4 candidates for treasurer. In how many ways can these positions be filled? The president has 4 candidates, so that means there will be 4 choices that we can choose from. Also, the vice president, which is 3, the secretary, we have 3, and the treasurer, we have 4. So, using the fundamental principle of counting, we can solve this, or we can determine by just multiplying 4 times 3 times 3 times 4, we can have 144 ways. Therefore, there are 144 ways to fill these positions. How about example number 5? So we have here a new license plates for cars in the Philippines come in 3 letters and 4 digits format, like this one, LTO 1234. These are just one of the examples of license plates in the Philippines having the format of 3 letters and 4 digits. So question letter A, how many license plates in this format are possible? And question letter B, of these, how many will have all their letters and digits distinct? Okay, let's solve first letter A. So how many license plates in this format are possible? Using a fundamental principle of counting, we all know that there will be 3 letters and 4 digits or numbers in the license plates, right? Now, in the first 3, we all know that there will be 26. Why 26? Because there are 26 letters to choose from A to Z, right? In the second letter, how many are the choices to? Still, there are 26 letters to choose from, right? In the third event, it's still a letter. So how many letters we can choose from? So there are still 26 letters to choose from, right? It could be AAAs, AAB, AAC, right? Or ZZZ. So there are 26 letters to choose from. Now let's go to the digits. How many digits we can choose from? We have 10. Why 10? From 0 to 9, we have 10 in total, okay? The same with the fourth, the second, the third, and the fourth digit. So there are all 10 choices. So using the fundamental counting principles, we will just multiply all of those, and that is equal to 175,760,000 possible ways. Therefore, there are 175,760,000 license plates in this format. Okay, how about letter B? Of these, how many will have all their letters and digits distinct? When we say distinct, it's different letters and different digits. So repetition is not allowed here. So that means A should not be repeated, B should not be repeated, 1 should not be repeated, 2 should not be repeated, okay? That means distinct. Okay, so take note, the first 3 events are for the letters. The four events will be for the digits. So in the first event, choosing a letter, we have 26, right? You can choose there A. So if you choose A, in the second event, you should not choose A because you already have chosen A. In the second event, how many choices we can have? There will be only 25 choices. Why? Because you already choose A. So if you choose A, there are only 25 letters you can choose from B to Z. There are 25, right? Because the question here is distinct letters, so A should not be repeated again. So there will be 25. So that means in the third event, we can choose 24 letters, right? Same with digits. In the first event of choosing a digit, there will be 10. Since example, you choose 0 there. So in the next event on choosing digit, there will be 9 numbers or digit to choose from. Next 8, next 7. When you do multiplication or the fundamental counting principles, that is equal to 78,624,000. These are the number of license plates if letters and digits are distinct. How about example number 6? Suppose an experiment consists of tossing a coin 4 times. How many different outcomes are possible? Letter B. How many outcomes have at least one head? Letter C. How many outcomes have at least 2 heads? Letter D. How many different outcomes have exactly 3 heads? This kind of example is difficult when you are not going to list all the possible outcomes or the possibility. So you need to use a tree diagram or a table for this. So if you're going to solve this kind of problem, this is what the table or this is a tree diagram. So when you first toss, it could be head or tail. In the second toss, it could be head. In the third toss, it could be head. In the fourth toss, it could be head. So the first outcome is head, 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 head. Now these are the outcomes here. In total, there are 16 possible outcomes. Here, the one with circle. So those are the possible outcomes. Means first outcome we have head, 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 head. Second outcome we had head, 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 tail. Third outcome head, head, tail, head, and so on and so forth. Okay. So in letter B, how many outcomes have at least one head? One head means only it could be 2 or it could be 1, 2, 3 and so on. So in counting there, I mean 1, 2, 3, 4. It could be 1, 2, 3 or 4 heads. So we will count. Try to look at the outcomes there. Only one outcome which is not possible for this question, letter B, which is T, tail, 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 tail. It does not have head, right? So we can say there will be 15 possible outcomes if you are going to have at least one head, right? Okay, let's go to letter C. How many outcomes have at least 2 heads? There will be 11 possible outcomes. Why? At least 2 heads means 2 heads, 3 heads, or 4 heads. So how many are those? So you will just count here the outcomes. These are not included. HTTT, THTT, TTHT, TTTH, TTTT, because they contains only one head. So while the rest, those are 11. We have there 11 possible outcomes. Okay, so let's go to letter D. How many different outcomes have exactly 3 heads? Exactly 3 heads. It's not at least 3 heads, not at most 3 heads, but exactly 3 heads. So in here there will be this one, exactly 3 heads. Let's go to example number 7. How many 7-digit telephone numbers are there if the numbers do not start with 0, 1, or 2? Okay, again, 7-digit telephone numbers. So our solution using the fundamental counting principles. Again, there will be 7-digit telephone numbers. So in the first event, how many numbers we can choose from? Do not start with 0, 1, or 2. Again, there are 10 numbers in total, and the first number should not contain 0, 1, 2. That means we could have 3, 4, 5, 6, 7, 8, 9. So how many numbers are there in total? That means there are 7 numbers to choose from. So that means, oh, here we have 7-digit telephone. So the first number is 7. Why 7? Because it should not start with 0, 1, or 2. So there will be 7 numbers to choose from. It could be 3, 4, 5, 6, 7, 8, and 9. The second number, how many are the choices? We have 10. Why 10? Because there are 10 total numbers to choose from 0 to 9. The same with the next to the last digit. And get the product, that is equal to 7 million. You can say that there are 7 million 7-digit telephone numbers. Okay, we have here a reflection. What can we reflect from this topic? Until 2013, the plate numbers of cars in the Philippines came in 3 letters and 3 digits format. In 2014, the new license plate numbers in format LLLDDDD were released. What is the advantage of adding another digit? Why do cars, buses, trucks, vans, motorcycles, and tricycles have to have license plates? Do an internet research on uses of license plates.